In starting chapter 8, we're now going to solve some more complicated trig function equations. And what we're going to do right now is solve it, and then we'll take a look at the graph and see how they relate. Now we've done stuff similar to this. We're going to solve for this by finding the inverse cosine. Now note we want all the solutions to this equation within this domain, and so we're going to use the lowercase for what our book uses. So now take out your calculator. First, check to make sure you're in the proper mode. I'll look at it with my graphing calculator. So I have inverse cosine of 0.42. Remember, mode is right next to the second key here. And yes, I have degrees, so that's good. Hit second quit, and now I hit enter. And it gives me the 65.16, so theta is approximately equal to 65.16. Now, typically we'll go to one decimal place when we're talking about degrees and 2 decimal places when we're talking about radians. Now, what did I forget right away? And I should have done this immediately. My unit circle. Always, always, always draw your unit circle. So we have cosine equals 0.42. That's a positive number. Cosine is x on our unit circle, so it's somewhere less than half. The exact spot really doesn't matter much. I just want to see that you know the general location. So we have 2 answers, and the calculator gave us 1 answer. Now, how do we find the other one? We got to remember what we did in the last chapter. So this angle there is theta, so that means this other one, we can prove those 2 triangles are congruent by hypotenuse leg. And that's going to be theta, so if we go all the way around, it will be 360 minus 65.2. Now what I want you to always do is use that whole decimal on your calculator. The easiest way to do it, there's a couple ways we can do it. We can say 360 minus, and then press second and the negative sign to get answer, and that will do it. And I'll show you another way in just a second. So we have 2 answers, 65.2 and then 294.8 degrees. Now in this case it does work out okay if you had used the 0.2, but it will not in general work out for radians. Now let's take a look at this graph. We're going to graph this. What we're going to do is graph y equals cosine of theta, and then we'll graph y equals 0.42. Now what's y equal cosine of theta look like? First, our key thing is taking a look at cosine of 0. Cosine of 0 is 1. Now remember, we did a little bit of the graphing last chapter. We're going to mark our key values here. Pi over 2, pi, 3 pi over 2, 2 pi, and that's all we want to do anyways. Oh, let me change that. Should have been 90 degrees, 180 degrees, 270 degrees, 360 degrees. It's very rare for me to graph in degrees. Cosine of 0 is 1, cosine of 90 is 0, 180 cosine would be -1, and then 0, then 1. Note we're going high, mid, low, mid, high, and we connect the dots the best we can. And it looks something like this. Now let's graph y equals 0.42. That is a horizontal line going through 0.42. Mine's a little bit off. I did it a little too high there, but it's okay. We can see though, and this is what I want to look at, that there are 2 solutions between 0 and 360, and we can see that we got both solutions. So doing that graph can be a check of what you did, and it's not a perfect graph, and that's okay. On the next one we have cosecant. Now instead of dealing with cosecant, let's change that to 1 over sine. So if we have 1 over sine of theta equals 14, remember if 2 fractions are equal, and we can call this 14 over 1, then their reciprocals are equal. So we can say the sine of theta equals 1 over 14. Now we'll take a look at our unit circle. Always the first time when we get it to sine, cosine, tangent equals to a number, that's when we want to do our unit circle. Now, sine is y, and y equals 1/14. Now, we're not going to definitely graph 1/14 accurately. We can just graph some small number, and we can see we have two solutions here. Take out your calculator, and we have inverse sine of 1/14. Now, go back and change your calculator and put it in radian mode. Hit the mode and change it to radian. If it's on the scientific, you can use your DRG button. And we get inverse sine of 1 divided by 14. 0.714, etc. So it's approximately 0.07. Now, what we want to do is find that other angle. So we know that this small angle there is 0.7 and this angle is 0.7, but we want to come all the way around starting with the x-axis. Well, the angle we're looking for plus this theta adds up to pi. So we have pi minus the 0.07. Now I'm writing that, but that's not what I'm going to do. I want to do pi minus answer, or another way I could do it is I could say answer minus pi on my calculator and just realize that it's the opposite sign of that. So the answer would be 3.07. It's more of a coincidence that it turns out to have the 0.07 there. We have two answers. Let's take a look at the graph. We have 1, -1, and this time we are in radian mode. So we're going to always mark the 5 points that you are dealing with when you're graphing sine or cosine. And if it's 0, you don't need to mark that one. Remember, if we're graphing cosecant, we're going to start with sine. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. 3 pi over 2 is -1. And then 2 pi is 0. So let's put this dotted, since we don't really care about the sine graph. Our goal is to graph the cosecant. Remember, if 1 over the reciprocal of cosecant's or cosecant's the reciprocal of sine, or 1 over sine, which means we have 1 over 0. We have an asymptote. And hopefully at this one, this jogs your memory to realize it was those parabola-like shapes. Remember, they're not parabolas. And it's going to come up here, and it'll have a vertical asymptote at 0 and pi over 2. And between pi and 2 pi, it's negative. Now we're going to be graphing here 14. That's some big number. And I'll just graph something up here. We can see that there are two solutions here. Now let's look at the relative size of those two solutions. We have something that's going to be close to the x-axis. That's our 0.07. And something just before pi. That's our 3.07. Similarly, I didn't actually do that for over here. We had 294. And that's going to be a bit bigger than 270, yes, and something less than 90, which is our 65. So it seems to give us some indication we did it right. The next one, 5 tangent. The goal when we see any other stuff with our trig function is we want to isolate our trig function. We want to get it by itself. So add 2 to both sides. 5/3 tangent of x equals 2 1/4. And what is 2 1/4? That would be 9/4. Now we get to get tangent x. So what we want to do right now is do it all in one step. Multiply by 3/5 to both sides. So we're going to get 27 over 20. X equals the inverse tangent of 27 over 20. Type that in on your calculator. Oh, before we do that, we should do our unit circle. 27 over 20 is slightly greater than 1. So remember, tan of 45 is 1. So it's going to be something here. And for tangent, we draw a straight line. So we have one angle here and another angle goes all the way around. So type in on your calculator, and what does that give? That gives 0.93 when rounded there. Now, how are we going to get that second angle? Well, if this is my x, I was going to write theta. If this is x, then I have that x value, and then I'm adding the angle of a line, which is just 180, or in radians, it'd be pi. So we have 0.93 plus pi. Remember, on your calculator, all you'd have to do is hit plus pi, and we get 4.07. On this one, we're not going to go ahead and graph that thing. Let's take a look at this next one. We're going to talk about graphing this line. You already know how to graph that. We have a slope of 2 and a y-intercept of 4. So we'll start at 0, 4. And a slope of 2, rise 2, run 1, or we can go down 2, left 1. And now we need to connect those dots. Get a ruler. And what I want to do right now is find the angle the line makes with the x-axis. That's this thing. So what do you notice about this? What do you see? What shape do you see here? Because our goal is to find, I'm going to call this angle alpha. I see a triangle. Well, what can I set up for that triangle? I know what this distance is, and I know what this distance is. Tangent of alpha equals, this is 4. Now, what I could do is use my slope, go down 2 again over 1. Yes, that is indeed 2. Now, I'm taking into account that I'm just looking at the positive nature of this. This is a 2 and then 4. I'm not looking at what the coordinates of this point is. So I get tangent of alpha equals 2. And for this one, I want to be in degree mode. So this is inverse tangent of 2, and that's approximately equal to 63.4 degrees. On your calculator, you should have 63.434, etc. So the angle that this line makes with the x-axis is 63.4. Let's try this again, and we'll do the next problem. We have a slope of 1/2 and a y-intercept of -3. So we go up 1, right 2, up 1, right 2, up 1, right 2. Take out your ruler, connect the dots. Now on this one, you can't really see that angle very well, but it's still that same basic spot. This is alpha. Now what can I do with this one? Well, if this is alpha, we can remember our geometry. These are vertical angles, so this one's alpha. I have a triangle here, and what can I say about that triangle? I know what this piece is, and I know what this one is. It's crossing over at 6, and it's going down 3. So we can say, again, tangent, because it's opposite and adjacent, just like this previous one was opposite over adjacent. Tangent of alpha equals 3 over 6, which is 1/2. So alpha equals the inverse tangent of 1/2, which is approximately equal to 26.6 degrees. Now, take a moment to look at those. You have to hit pause, but look at them. And what do you notice about the equation we came up with, this tangent equation, and the original equation? Do you notice anything similar in there? Well, we have tangent of alpha equals 2. Where do we see that over here? That's right there. We have tangent of alpha equals 1/2. Where do we see that 1/2? Again, that's that spot in front of the x. What's that called? The slope. And it turns out it's always that way, no matter what direction the line goes, because we could have set up, for example, a triangle. Let me pull this over. like this, and that triangle would be similar to this triangle, and so the ratio of sides would still be the same. In general, the slope of a line equals the tangent of alpha, where alpha is the angle the line makes with the positive side or positive direction of the x-axis. So what I mean by that, when we take a look at this example, the positive side means going to the right. Alpha is called the angle of inclination. It's that angle the line makes with the x-axis. And one thing you have to remember is that alpha is always going to be measured in degrees, and it has to be between 0 and 180 degrees, including 0, not including 180. In problem number 1 and 2 for this lesson, I told you exactly in N3 what the domain, that we are in radian or degrees. Over here, you have to recognize when you're dealing with an angle of inclination problem that it's in degrees. And that'll be enough for today.